Hello guys, so welcome to my channel. So in this video I will be explaining about the microservices architecture. So these are all the topics that I will be explaining in this video. So first we will see what is the typical system design, microservice architecture, API gateway, services, management or orchestration, inter-service communication, in that synchronous and asynchronous, data management and observability. So first we will see the high level system design, how high level system design works. And these are all the layers that will be present in developing the applications. So first we have the client layer. So the client layer will send the request to the edge layer. Edge layer we have something known as domain DNS, CDN, API gateway, load balancing, everything comes in the edge layer. After that the request goes to the application layer. The application layer has the application deployed, and we can have multiple services deployed in the application layer. Then the application will communicate with a database, and once that is done, so we can have observability layer. So that is where monitoring and logging comes into the picture. So this is the high level system design. So let's drill down what are the components that will be coming in each layer. So let's go to the big picture of system design. Yeah, this is the big picture of system design. So as I mentioned, the client will be there. The client will be sending the request to the edge layer. In the edge layer we have the DNS, that is what we call it as the domain naming server. So there with the URL resolution will happen here. We have the CDN, that is content delivery network. We have the load balancing or the API gateway. So based on the request, so it will the API gateway will send the request to the particular server, particular app server. Then we have the application layer where the different services will be deployed. Like the request goes to this application layer. So before caching and async, the application layer will be communicating directly to the database. Like we can have primary DB, or you can use NoSQL database, and with the help of this we can directly read and write to the database. And when it comes to database, you should know of these concepts like what is database replication, database sharding and database partitioning. So finally the last layer is observability. In the observability layer we will be doing monitoring and logging. So here the communication between the application layer and the database layer will have a latency. So what is latency? The latency is nothing but the response time in order to send a receive the request and send a response. That is known as latency. So that is the bottleneck over here. So in order to solve this problem, that is the latency between the application layer and the database layer, we have introduced cache in between. You can see in the diagram we have introduced cache, so that if there are any frequent access data, that like for the first time it will go to the database and store that data in a cache, and if any request asks for that data, then it will return from the cache itself. And if there are any write operations, then it can go and perform in the DB. And another thing is asynchronous communication comes into picture. So in order to reduce the latency, between application and database layer, we can have async communications like messaging queues. There we have the worker nodes in the, like the application will put the events into the messaging queues, and the worker nodes will take the events and store it in the database. That is how the async communication works. Here we can use like the messaging queues such as RabbitMQ and Kafka. And now, so actually, I need to explain the microservices architecture. Why I am explaining the system design? So the microservices architecture also follows the same pattern system design, but instead of in the edge layer, we are following. There are so many components, right? So we will be having some like the main component is API gateway. The same, then it will connect to the application, then the cache, database, observability. So almost if you know this high this actually this is the high, if you want to know the bigger picture of system design, so this is the high level picture of system design, and also this is also the microservices architecture as well. Now let's see how the microservice architecture looks like. You can see the same thing, the microservice architecture which is coming. Yeah, this is the microservice architecture. So we have the client and all the services, all the components that I have discussed. So let's discuss this one by one. So we have the client. So client will be sending the request to the API gateway, that is in the edge layer. We have the API gateway. So API gateway is responsible to route the request to a particular microservices. Let's look at what is API gateway. So you can see API gateway is a single entry point that routes the client request to the appropriate microservices. And also API gateway is responsible for routing the request, that is sending the request to appropriate microservices. Handles authentication. Here also here only in the API gateway only we can handle the authentication and applies rate limiting, and we can log the request in the API gateway. So these are all the functionalities we can do it in the API gateway. Next comes the another component, that is management or orchestration. And here in this component we have the application. So that means the multiple services are deployed over here in this layer, and all these services can talk to each other. That is what we call it as inter-service communication. So let's go to management or orchestration. So what is management or orchestration means? It manages the deployment, scaling and availability of services across infrastructure. So that is, this layer is responsible for deploying the services across servers, restart failed services and auto scale based on the traffic. If there are multiple requests coming to the order service, it can do horizontal scaling and increase the number of instances of the order service. And in the there is something known as the service registry. What is service registry means? For example, your product service is calling the order service. How it will call means, you will configure that order service URL in the product service. What if the URL changes? Then the product service will not be able to call the order service, right? So in that case, service registry comes into picture. So in the service registry, we will be registering all our microservices, and whenever the product service not able to find the URL of the order service, it can contact the service registry, so that we are updating all the services over in the service registry. That is one point you should be keeping in mind. And as I discussed, how the services communicate with each other, that is inter-service communication. One is asynchronous, one is synchronous, and another one is asynchronous. In the synchronous communication, we will be using various type of REST clients like REST template, Fing client. And in asynchronous communication, we will be using messaging queues such as RabbitMQ and Kafka. Actually, this inter-service communication is different. That is like inter-service communication between the product service and order service. And here I explained, right, this communication between the application and the database. This is different, but we will be using the same tools for in order to achieve this. But both are different things. Next, we will be talking about database management. So let's talk about what is database management. Database management, here each service have its own data and database independently, as you can see in the architecture diagram. So every service has a user as a independent database, like user service as a separate database, product service as a separate database, and order service as a separate database. And you can combine, like for user and product service you can have a single database, and order and payment service you can have a single database. Even that is also fine. And also for user service you can use MySQL database, and for product service you can use NoSQL database. That flexibility is also there in this microservice architecture. That is what we call it as database management. So this is database per service. Every service will have a separate database, different DB types possible. That is, one service can have MySQL, one service can have NoSQL, and no shared databases. So this is all about the database layer. Next comes the observability layer. The observability layer means once we application is deployed, we will observe the behavior of our application with the help of monitoring, centralized logging, and distributed tracing. So in the observability we have this what does observability layer gives means observability layer provides a visibility into system behavior through logging, monitoring, and tracing. So what is centralized logging? Centralized logging means all these microservices, like the logs from all these microservices will be logged in a centralized place. And what is distributed tracing means, for example, you're sending on client request, that request is going through some all these microservices, user service, product service, order service, payment service. Then we will trace the request from the starting to the end, that is known as distributed tracing. So these are all the things like centralized logging, monitoring, and distributed tracing. We will be doing it in the observability layer. So this is the high level architecture of your microservice applications. And if you have any doubt, please type it in the comment section. And thank you so much for watching.